The renowned space race between the United States and Russia brought out the best in these two nations. Now, a new space race has emerged, pitting the US against a formidable competitor, China. What adds a unique twist to this competition is the involvement of a private company, SpaceX. China, in its quest to explore space, is going head-to-head with both the US and SpaceX by constructing an extraordinary 800-meter rocket. The intriguing question that arises is, what exactly is this unconventional rocket that China is developing? And can it potentially surpass the capabilities of the US and SpaceX? We invite you to join us as we delve into all the information China has disclosed regarding its towering 800-meter rocket in an attempt to outpace SpaceX and the US. When discussing space exploration, many may recall the historic rivalry between the US and Russia as they vied for supremacy in various space achievements. However, the landscape has shifted over time, and today, we find the US and Russia collaborating in matters related to space. Notably, they jointly operate the International Space Station, reflecting a spirit of cooperation. In fact, Russia has been responsible for ferrying US astronauts to the space station for a fee, while the US has frequently procured rocket engines from Russia, highlighting the evolution of their relationship in the field of space exploration. The space race has evolved to include new participants, encompassing both government entities and private enterprises. Among the most successful private companies is SpaceX, founded by the world's wealthiest individual, Elon Musk. In a remarkably short span of time, SpaceX has risen to prominence, emerging as a central player in the American space industry. The company currently operates two in-house developed rockets, the Falcon 9 and Falcon Heavy, which are routinely employed for launching payloads into orbit. Notably, SpaceX serves a diverse clientele, including NASA, which relies on SpaceX's Crew Dragon capsules for transporting cargo and crew to the International Space Station, ISS. SpaceX also conducts missions for various private companies, such as satellite launches, and enjoys prestigious collaborations with the US military. Notably, SpaceX is forging ahead with the development of its groundbreaking rocket, the Starship, an unprecedentedly powerful and towering spacecraft. Elon Musk envisions the Starship as the key to his ambitious plans for Mars colonization. China, a formidable Asian powerhouse, has also entered the space race, marking a rapid ascent in its space endeavors. From 2016 to 2021, China launched an impressive total of 207 space missions. However, their ambitions continue to grow. China launched the core module of its new space station, Tianhe, in April 2021 and subsequently dispatched 2 astronaut missions to the orbiting laboratory, one in June and the other in October. The country's comprehensive plan involves the completion of the space station by launching 2 additional modules, known as Mengtian and Wentian. In parallel, China is actively constructing a space telescope named Zhanshan, which will orbit at the same location as the space station and periodically dock with it. The anticipated launch of Zhanshan is set to occur within the next 5 years, and the space station is expected to see extensive utilization during this period. Astronauts will inhabit the station for extended missions, engaging in diverse research and maintenance activities. China has set ambitious goals, including lunar exploration and Mars missions, which have garnered considerable attention. In the coming 5 years, the country will focus on advancing studies and research for human lunar landing, developing next-generation crewed spacecraft, and exploring essential technologies to establish a foundation for lunar and deep space exploration. China has made significant strides in its space endeavors. In January 2019, the Chang'e 4 mission made history by achieving a soft landing on the far side of the Moon. In December 2020, the Chang'e 5 mission successfully brought back pristine lunar samples to Earth, marking the first such accomplishment since the 1970s. In February 2021, China's first entirely domestically developed interplanetary mission, TIANWEN-1, entered orbit around Mars. In May of the same year, the Zhurong rover separated from the TIANWEN-1 orbiter and executed a successful landing on the Martian surface. Notably, Zhurong has been actively exploring the rocky terrain of Mars, with videos capturing its progress since landing in May the previous year. The rover's primary objective is to uncover clues regarding the possibility of past life on Mars, although definitive answers are yet to be found. It's worth noting that, after the United States, China is the second country to successfully land and operate a rover on the Martian surface. China's persistent drive in the realm of space exploration remains evident as the nation embarks on an ambitious project that has the potential to surpass the International Space Station, ISS, in terms of scale. The ISS, a remarkable engineering feat, stretches approximately 357 feet in length and 246 feet in width, equivalent to around 109 meters long and 75 meters wide. The construction of this colossal space station was no small undertaking, necessitating over a decade of effort and more than 30 missions. Notably, it represented a monumental collaborative endeavor, with 5 space agencies from 15 different countries contributing their resources and expertise. The financial commitment was substantial, with an estimated cost of $100 billion for its construction and annual operational expenses of approximately $4 billion. In a unique twist, China currently finds itself excluded from participating in the International Space Station due to a congressional act that restricts NASA from engaging in direct bilateral cooperation with the Chinese government or any affiliated organizations. This exclusion persists despite China's demonstrated capacity for constructing immense structures, as exemplified by the historic Great Wall of China. What sets China's aspirations apart is the audacious plan to construct an enormous space-based structure, as detailed in a project outline released by the National Natural Science Foundation of China. This project, focusing on the assembly mechanics of a mega-sized spacecraft, stands as one of the initial major undertakings set to be explored over the next 5 years. Experts, captivated by the sheer ambition of the endeavor, also foresee a multitude of potential applications for such a colossal spacecraft. Among the most captivating possibilities is the concept of space-based power plants, capable of generating electricity for our planet. These forward-looking power plants could consist of massive, modular spacecraft, orbital telescopes, and other components that would come together to form colossal megastructures once placed in orbit. As China continues to push the boundaries of space exploration, it remains a subject of great interest to see how this ambitious project unfolds and what new frontiers it might unlock in the field of space science and technology. The motivation behind China's pursuit of a colossal spacecraft is rooted in the evolving landscape of space technology and the growing demand for space missions, which traditional spacecraft manufacturing, deployment, and launch methods struggle to meet. Researchers from the Chinese Academy of Sciences have underscored the need for innovation in space technology. They emphasize the advantages of in-space assembly technologies, which can adapt to the construction of large space structures, enhance spacecraft performance, and reduce operational expenses. This vision aligns with the Chinese government's call to scientists, urging them to explore novel lightweight design approaches to minimize the amount of construction material needed in orbit. Moreover, they are seeking innovative techniques for the secure assembly of these massive structures in space. The primary hurdle in this ambitious endeavor is the substantial cost, considering the immense expense associated with launching objects and materials into space. For context, the International Space Station, ISS, cost roughly $100 billion, as mentioned earlier. Constructing something 10 times larger would undoubtedly strain even the most generous national space budgets. Nonetheless, the final price tag hinges on the specific structure China decides to build. For instance, the ISS is equipped to support human habitation, which significantly increases its mass. However, if China is contemplating a structure that is lengthy but not overly heavy, it could lead to a different cost calculation. Innovative construction techniques have the potential to address the challenges and cost considerations associated with launching an enormous spacecraft into space. The conventional approach involves assembling components on Earth and then piecing them together in orbit, akin to building with Legos. However, an alternative solution lies in 3D printing technology, which can convert compact raw materials into structural components of much larger dimensions directly in space. Another intriguing innovation centers around sourcing raw materials from the Moon. The Moon's lower gravity, in comparison to Earth, offers a more favorable environment for launching materials from the lunar surface into space. Nevertheless, this concept necessitates the establishment of launch infrastructure on the Moon, making it a long-term prospect. The development of such a massive spacecraft presents further challenges. When subjected to external forces, Whether during orbital maneuvers or docking with other vehicles, the motion imparts energy to the spacecraft structure, resulting in vibrations and bending. With a structure of this scale, these vibrations can persist for an extended duration, requiring the implementation of shock absorbers or active control systems to mitigate them. Designers must also make deliberate decisions regarding the spacecraft's orbital altitude. Lower altitudes encounter atmospheric drag, which necessitates constant thrust to maintain a stable orbit. This challenge is already faced by the International Space Station, ISS, but for a substantially larger structure with increased drag, the demand for fuel to maintain its position becomes a significant concern. On the other hand, launching to higher altitudes is a costlier endeavor, and radiation levels intensify as objects move further from Earth's atmosphere. This poses a challenge, particularly if the spacecraft is intended for human habitation. One promising application for China's ambitious mega spacecraft is its potential use as a space telescope. A telescope of such magnitude could potentially offer insights into exoplanets in other solar systems, including their surface features. We look forward to hearing your thoughts on China's new mega spacecraft in the comments section below.